Hey Tooth Engineers, what's going on? This is Bioman, and today we have a special guest with us today. Jondra, who is a PhD student at Virginia Tech, knows a lot about data science, and not just data science, but data science and dentistry, which will be the topic we're discussing today. So Jondra, before we get into talking about dentistry and AI, because that's very nascent, tell me a little bit about what you do and why you like data science so much.
So really what I do right now is I work primarily in radiomics, which is taking kind of nascent information within medical imaging, so that's like x-rays, CTs, MRIs, and then generating that into usable data for clinicians. Typically what's happening in medical imaging, at least in some of the more standard imaging protocols, is that practitioners are looking at imaging and they're using their training and their judgment to kind of understand what's going on within that image, but that's not always the most accurate. So essentially what radiomics does is try and make it into a quantitative metric. The way that I liken it is like a blood test, but for images. And then where you can take that data science is that there's a lot of different pathologies that can arise and that you can diagnose within medical imaging. So I work primarily in the spine. So you have different pathologies like myelopathy, pseudoarthrosis, spondylolisthesis. This is all a bunch of medical jargon that I'm sure you don't understand right now. But
I'll send the Tooth Engineers, but hey, it's your PhD. You gotta own it.
Yeah, send me an email. And what you can do is you can take all this breadth of information and then you can link the different variables that you have to these different types of pathologies, different outcomes, different diseases. And that's kind of where machine learning and artificial intelligence for most of its existence has lived within medical applications.
Now, you brought up this important point about basically assigning quantitative numbers to diagnostics. What is your basis for establishing these quantitative metrics in a broad sense? How do you sort of like say some pathology is a 1 or 0, or what makes you determine the rules for assigning numbers and things?
So there's a lot of different, good questions. So there's a couple different schools of thought. There's some pathologies where you don't know how they act, how they look. So that's where you kind of have to get into the characterization of these pathologies. So you can do something that is unsupervised learning, where you just essentially take all the information that you have about, X, Y, and Z disease, and you throw it at artificial intelligence, and it says, okay, here are, based off of this grouping of data, these are like the most important variables. A pretty important algorithm that people use for this particular thing, it's not necessarily a deep learning or unsupervised, is a random forest where you already know what the outcomes are. So you already know what the different diseases are, but you don't know what the most important feature is or what the most important groups of features are. Where you put it in and then it will select these different features and it'll split them up in different combinations, and based off of they call it the Gini coefficient or the purity coefficient. So based off of this spread or this selection of variables, how pure your outcome is. That way you can kind of figure out, okay, here are the different thresholds for different variables.
And are these features drawn by correlations or something more nuanced than that?
I guess it's a little bit more nuanced than that. It is based off of the purity of your stratification. So when let's say we have one, like a blood value, like some blood serum value. Let's say there's a random arbitrary cutoff, and then you split your data based off of that. What is the purity of the diseases that fall above and below that variable? And then if let's say it's 50-50, that's not a good cutoff. But if your cutoff becomes 99-1, like 99% have it, 1% don't, then that would become a good threshold for that. So that is kind of the most approachable version of that.
Makes sense. But essentially it's you're drawing these conclusions from just pattern recognition, essentially, from each of the features that a random forest would say, this is defined as what's most important to determine that this is the disease pathology you're looking at.
Yeah. And then there are other methods that you can do where you have more of a supervised machine learning. Those are the ones that are
They learn themselves. So we're talking now like the ChatGPTs.
So when you get to the ChatGPT, those are large language models. So those are more akin to the unsupervised learning models, where they kind of learn on the fly and they're constantly bringing in information and they're linking it to other data points.
I see.
So those large language models, that is a section of deep learning. So artificial intelligence is like that big umbrella that everyone thinks of. When you think of computers making decisions, artificial intelligence, and then you have machine learning, and then it kind of keeps going down, and then you have your deep learning, which is the deep learning, then you have unsupervised, and then you have your LLMs, which is kind of right now, that's the most advanced thing that we got, where it can take essentially somebody giving you like decisions, or not decisions, you give it words, you say, okay, here's this abstract idea, and then it takes those abstract ideas and links it back to...
So maybe just to speak more broadly, because this is probably a very important distinction to make and something that I'm even somewhat unaware of. Supervised versus unsupervised learning. At least my understanding is that one just sort of looks at things based on patterns and the other kind of adapts based on what you give it. Is there anything more that we need to know that helps us determine the difference between these two kinds of like ways of learning in machines?
Yeah, so supervised is essentially you already, not necessarily you know the outcomes, but supervised learning you kind of have more of a control over its training, how it splits the data up, whereas deep learning it's more unstructured. You just kind of give it the information and then it learns itself. Supervised learning, you take more of a active role in the training and then what the outcomes are. With deep learning, you might not necessarily know what the outcome is.
Right.
Like, here's this bin of data, figure out how are they different? What's the difference between
So
these
which of the two would you say is like more adaptable and akin? So you were basically saying that like all of the LLMs is more akin to just like we have no idea what's going on. We put stuff in and then it's just going to kind of teach itself?
To an extent, it teaches itself.
And you would then also designate the LLMs more as unsupervised over supervised? Or it depends on sort of which
LLMs
program?
I would consider as more of an unsupervised.
Interesting.
Versus like a random forest, those are more of the supervised learning. Your k-nearest neighbors, that's like a supervised supervised machine learning. So, and the more simple models, those are typically the supervised learning. But I guess we need to bring it back to dentistry, like your more advanced machine learning models, like convolutional neural networks. So that's primarily for image processing. That's been really helpful with, like in my work with primarily medical imaging, but also in dental imaging. I think the company's name is Overjet. The way that their programs work is that they can identify caries or cavities, and based off of your previous imaging, they can say whether or not this cavity is progressing or if it's stagnant. So like if it's a stagnant cavity, chances are you don't need to focus on it too much. But if it's getting larger based off of previous visits, then some of that needs to be corrected.
Well, I mean, I think when it comes to like image analysis for X-rays, you really only have a limited number of colors to look at. So I guess my question here would be, what would AI do for something like an X-ray to diagnose a hole in a caries that, what would basically make AI more helpful in determining a hole is in a caries over a dentist seeing a hole in the caries? So
with X-rays, you don't have colors, but you do have a whole spectrum of density. So you have pixel attenuation. So let's say we're working on a standard scale from 0 to 255, 255 being super bright. If you have something that is 255, like that value is 255, then that's a super dense, area. If we're saying that bone is the most dense in the image, then that's bone. But if you have something that is slightly less than that, like on the lower end of the spectrum, let's say less than 125,
Yep.
then that's going to be something that is closer to air, because the air on an X-ray has a density of 0. So if you have something that has a lower density, then you can identify that as something that is missing attenuation. And what you can do with these CNNs is you can actually segment out different, I guess, anatomies based off of your training data. So you can identify like the pulp, you can identify the enamel, you can identify cavities based off of its location.
But effectively, we're talking about a continuum as opposed to like black and white of numbers between 0 to 255 for these different hues. And then this also then goes back to this question of what's the threshold between this 0 to 255 that we start just saying that something is more carious versus healthy tissue.
So that's where you kind of have to go into your training data. So machine learning is nothing without training data. I don't know that off the top of my head,
course, yeah.
but if you were to look at all the images, you could take like a histogram of whatever is identified as a cari, and you can select that out and be like, okay, what is the density at this point? But the way that most of these work is that you create a segmentation of these individual cavities, and whether or not that is a threshold based, like a pixel attenuation based, or that is manually kind of drawing in that segmentation, depends on how you want to do it. The threshold version, that's significantly more high throughput. So if you have a massive database, that takes a lot. Takes a lot less time. But let's say you have unlimited money and unlimited time, then you can rely on practitioner expertise to kind of segment out these different.
And would you sort of, in these sort of instances where, as you've mentioned, we don't have unlimited time and money, you train a database and it sort of creates this rule of, at least we're talking about caries, some level in that 0 to 255 continuum is considered a cavity. Would you believe that you guys could be wrong and a dentist could sort of say no, like, yeah, your data seems cool, like, okay, cool, you made 240 hue a cavity, but the dentist is like, I think something needs to be even darker than that for it to be a cavity. What do you do in those instances?
Yeah, so it's never going to be perfect. That's the thing. I mean, the more and more data that you have, the more and more close to perfect it'll be. But the fact of the matter is that AI just isn't there yet. It's never going to be perfect. So that's why it is not extremely foolish, but it is foolish to rely 100% and just trust AI and its results at face value. So the computer can always be wrong. But that's also usually the case with humans too. Humans could also be wrong, so there's kind of a balancing act where you look at these images and take it with a grain of salt. If anything, it can be used as a targeting measure to be like, okay, this identified a cari, this identified a potentially emerging cavity. Okay, now we need to go in and do a physical exam to see, is it actually a cavity? So relying on artificial intelligence to unilaterally make medical decisions is just not where we are in the field yet. If anything, it's just a suggestion or just like, okay,
it's
you
a
should
screen.
bring, it's a screen. And that's the way that most people have been using artificial intelligence in the broad sense of the term.
So I guess my last question to you would be, besides image analysis, because that's, dentists take a lot of images to make diagnosis, where else do you think AI could be useful in the space of dentistry?
So probably the first thing that people have used AI for is just straight up administration. Is taking, okay, here is a set of words that we have, like let's say we're putting in insurance, like an insurance claim. Okay, doctor said you need X, Y, and Z procedures. Okay, I'm gonna take this form. This seems like it fits in this box. I'll put it in this box. This probably means it costs this much. I'm gonna say this is how much it costs, and put in there. So just automating kind of that transcription between ordering and then putting it into like insurance companies. So just all the monotonous paperwork is the big one.
But would you say that's for all healthcare or just dentistry specifically?
That is probably all healthcare in general. That is like the first thing that people have done with that is to do that.
And I would think to your point, like, yeah, every medical industry right now sort of thinks AI is a doctor now, but it's really not. And I think the immediate, translation point of AI right now is, to your point, administrative work, not, diagnosing patients.
Yeah, I think what I think people need to understand, especially in using AI in medicine, is that it is extremely helpful, but it doesn't need to become just a really smart WebMD. Like, don't take it and be like, oh, based off of the results of this artificial intelligence, oh, you have like mouth cancer.
I mean, everyone has become a doctor with WebMD on Google. Just imagine how they feel with AI.
Now
everyone's better than a doctor at this point, right?
Yeah, everyone thinks so until they need one.
Exactly.
So it's really important that, especially in the medical practices, and dentistry is no different, that you need to be careful when using these using artificial intelligence. It can provide a lot of helpful use cases in dentistry, especially again, like we were talking about before, the big one being caries and needing certain types of, maybe you need a bridge, like something's decaying in your tooth, or you need a root canal, something like that. So it could be really helpful, but it's never gonna, or it might replace it eventually, but right now it just can't replace a physical.
And it can't
exam.
brush your teeth either.
No, it can't. I mean, whether or not 30 years down the road we are in some kind of WALL-E situation where we have all the robots doing it for us, who knows? The way that AI is moving, the rate that it's going, who knows how long that's going to take?
Right.
I think I talked about AI in dentistry a year ago, and the way AI has been a year ago before and the way it is today,
Scary.
Leaps and bounds different. So
Absolutely.
who knows? Everything I said today could be completely obsolete in another year.
But you guys still need to brush your teeth.
Yeah, preferably yes. Because again, robots can't do it. And I'm not going to lie, I probably wouldn't trust it. I don't think a gigantic metal arm brushing my teeth for me would be very comfortable.
That would hurt.
Yeah, because, I know how I like it. And, until they can recognize voices and be like, hey, man, back off.
Back it off a little bit.
Kind of take it easy. That doesn't seem like a pea-sized amount, maybe.
Ditto to that point. Well, Jondra, this has been a very engaging discussion, and we hope to see you around more.
All right, I try my best. Hope
Good
to see you
stuff.
soon.
Well, Tooth Engineers, we'll see you next time. Again, this is Bioman, and we'll see you around.